Hello, nice to see you on our video that discuss dynamic programming. So we continue with three approaches for algorithm design. We already discussed brute force approach, and now we switch to dynamic programming. So what is the dynamic programming? Let us discuss firstly the general idea. Assume that we have a problem and there is some parameter of this problem that can be recognized as the size of the problem. So parameter is such that if this parameter is small, then we can easily solve this problem. And if this parameter is big, then it is hard to solve it. So the main idea of dynamic programming is firstly solving the same problem with smaller parameter that is such that it is easy to solve these problems, store results of these solutions, and based on these stored results, we solve our big problem. So solving big problem based on already solved and stored results for the same problem but smaller. In fact, this idea is very general for solving problems. For example, if we use some brick to build wall, and we want to build wall of size 3, it is hard to take all these bricks together and get the wall of size 3. Firstly, for solving this problem of big size, so of size 3, we should build the wall of size 1. It is easy, we just put a brick, then we add some bricks to it and get wall of size 2. Then continue the same strategy and get this walls of size 3. So we take solution for this problem of size 2, already stored or already built wall, and add some bricks and get something bigger. As I say, this is very general idea. Like, I don't know, I want to prepare. I want to cook 20 pancakes for my 20 friends that want to come to visit me. How I can do it? I just have I just able to cook 5 pancake at the moment. So what I do, I cook 5 pancakes, put it to a plate, so store this result, cook 5 pancakes again, put it to the plate. Already I solved the problem for size of 10, then cook 5 pancakes again, put it to plate. Then I solve the same problem for size 15 and continue until size 20. Yeah, so we use this approach very often, but the same approach is used in some parts of math. For example, the one part is combinatorics. For example, n factorial can be solved using dynamic programming. What is the n factorial? N factorial, in fact, it is product of positive integer numbers from 1 to n. So for computing n factorial, what we can do, we can just multiply all numbers from 1 to n. But in fact, this way to compute it have time complexity O from n. But another way is computing n factorial is this one, n factorial is n times n minus 1 factorial. If n minus 1 factorial already computed and stored somewhere, then we can just multiply it to number n and get the result. And complexity of this solution is constant time complexity. So using this storing technique, we obtain constant time complexity, but not linear time complexity. Okay. Another another example is Fibonacci numbers. It is the numbers where that nth number is sum of two previous numbers, n minus 1 and n minus 2. In fact, if we compute it directly, so for computing number n minus 1, we take n minus 2 and minus 3. So for computing n minus 2, we take n minus 3 and minus 4, and so on. Okay, and also I can say that, for example, f0 should be 0 and f1 should be 1 for completeness. So if we solve this problem recursively, for example, then we obtain exponential complexity. But if we don't recompute the same number several times, okay, why it is exponential? Because, for example, for computing f6, we need f5 and f4. But for computing f5, we also need f4 and f3. For computing f4, we need f3 and f2 here. For computing f4, we need f3 again, f2 again, and for computing f3 here, we need f2, f1. So you see that number of, for example, f2, okay, here f2, f1 again. So number of computing f2 increasing exponentially. So here there are 4, but before that it was just 1. But if we store these values in some array and don't recompute it again, but just take the numbers from array already computed, already stored, we can obtain not exponential complexity, but linear complexity. Another topic where you can see this idea, general idea, is, for example, proof technique called math induction. So it's here for proving some concept. You firstly take base and then prove based on this base from the previous smaller claim, you get the same claim but for bigger parameters. So recursion can be also considered as same concept, same idea, but recursion typically don't need to. This recursion technique generally don't need to. You don't need to store these values, but here the dynamic programming requires to store the values that you already computed to don't recompute it. Okay.